Hello everyone, I am Nehal from WsCubeTech, and in this video we are going to talk about polynomial regression. So let's get started. So what is polynomial regression? So as you can just see, I have these two graphs over here, and if you just observe them carefully over here, so in this first graph you can just observe that these data points, okay, that is inside our data set are in linear fashion over here, okay. Whereas in this case, you can just observe that our data points are in non-linear fashion over here. So in this simple linear model, okay, as we know that the data points are in linear fashion over here, and if I just apply this linear regression over this first case, so I'm just going to get a good result over here, since the error rates would be also minimum, and I'm just going to get a good accuracy in this case. But say for example, if I just apply the same thing, that is the linear regression model over this case, okay, and you can just observe this data points over here. So these data points are in non-linear fashion. So you just assume that you're just going to get this way line. So in this case, you might see that only one point may come over your best fit line, okay, and all the remaining points are just lying outside that best fit line over here. Now, in this case, if you just go with this simple linear regression algorithm over here, so what will happen here? The error rate will increase, and that will just decrease the accuracy of the overall model over here. And in such scenarios where our data points are in non-linear fashion, we go for polynomial regression. So just let's have a look over our equations over here. So see, this is the linear equation with single variable, okay, that is y is equal to mx plus c. This is the linear equation with multiple variables, okay, and in this case, this y is nothing but the dependent variable, then x1, x2, x3 are the independent variables. This m1, m2, m3 are nothing but you can just call this as coefficient or slope or gradient, and this c is nothing but it is the intercept over here. So if you just observe in these two equations over here, this we have already studied with the help of implementation part, okay. So if you just observe here, the degree of this x variable over here, so it is raised to 1 over here, right? Which means that this is nothing but this is the 1 degree polynomial over here. So this linear model is just formed by making use of this 1 degree polynomial over here. Now talking about this degree of polynomial over here, so we have already seen this 1 degree polynomial, okay. Talking about this 0 degree polynomial, so when I just say 0 degree, so x raised to 0 is 1, and you are just going to get a constant over here, okay. This 1 degree is nothing but this is the same equation, okay, that is linear equation with single variable and linear equation with multiple variables. Talking about this 2 degree polynomial over here, so you can just see this x raised to 2, then plus this x, okay. And this a and b are nothing but these are the coefficient over here. So likewise, if you just go on increasing with this degree, you can just come up with 3 degree polynomial, 4 degree, 5 degree, okay. So if I just want to let you guys know that the generalized polynomial equation, so this is your generalized polynomial equation over here. You can just observe over here, so this y is equal to a of 0, then a of 1 x raised to 1, here it is 1, then plus a of 2 x raised to 2, then plus a of 3 x raised to 4. Likewise, you go till your n over here, okay. So this a0, a1, a3, a4, an, these are nothing but these are the coefficients over here. This y is nothing but this is a dependent variable, and this x is nothing but it is the independent variable, and each time what we are doing, we are just increasing the power of x over here. So this is all about what is polynomial over here. Now what we are going to do is we are just going to see the practical implementation of this thing. So we'll just head over to our Jupyter notebook. So I'm over at my Jupyter notebook over here. So what I'm simply going to do is I'm just going to import my libraries. So first I will just import this pandas, Jupyter alias name as PD. I'm just going to import this matplotlib library in order to do the visualization. And I'm even going to import this Seaborn library. Once I have just imported all of this library, the next thing what I want to do is I need to load my data set over here. So I need to just provide here the path of my data set. So this is my path, that this is my data set, that is the position salaries. I'm just going to go into the properties and I'm just going to copy this location over here. Even I need to copy paste this name of my CSV file over here. That's it. And this is going to be my data set. So I'm just going to I will just provide you this data set link, okay, at the description box below. You can just go to that link and you can just download the data set for your practice purpose. And if I want you guys to see the data set over here, so this is the data set over here. So it is having this columns such as position, label, and salary. You can see these are the positions, these are the labels, and these are the salaries over here. So now what we need to do over here is that we need to just divide this data set into independent variable and dependent. Okay, so this label is the independent variable while the salary is the dependent variable. Okay, because the salary is dependent upon the label. Alright. Now this simply means that what we need to do is I'm just going to write here x is equal to, and I'll just say data set I log, and inside the square bracket I need to say I want all the rows and I want this label over here. So what I will simply do over here is I will just say that start with 1 and go all the way till 2. Okay. So here 1 is included, 2 is excluded. Okay. So this position is 0, then label is 1, then this is 2. So it will just start with this and it will not go with this because this 2 is excluded over here. Now if I just run this thing over here and if I just show you guys my x over here, so I'm getting this type of data, but I want it in the form of arrays, right? So what I will simply do is I will just say here value. And now if I just show you my x, so I got this array in this case. Okay, fine. Now similarly what I need to do over here is that I want my y variable as well. Okay, so I'm just going to say y is equal to and data set dot ilog, and inside this what I need to say, I want that all the rows and I want this 0 1 2, that is my salary column only. So I'm just going to say 2 over here. And similarly I am interested in arrays, so I'm just going to say y. And if I just show you my y, so you can see I got an array and these are my y. So I just separated out my x and y variable, that is independent and dependent variable over here. Now in order to just visualize your data points over here, what you can simply do is you can just plot your scatter plot over here. So what I'm simply going to do is clear scatter, and inside this I need to pass my x and y. And you can just observe over here, okay, these are your data points over here. So these are in non-linear fashion over here. And similarly, if you just want to draw best fit line, so what you can do is you can just go with this LM plot under C1. So I'm just going to say this as LM plot, and over here I need to pass this x is equal to, then y is equal to, and data is equal to my data. So here my x would be the label, my y would be the salary. Yes. So see, this is my best fit line, okay, that is the regression line over here. And you can just observe only one point is coming here and rest all the points are lying apart from this thing. So definitely the error rate would be more if I just go with the linear regression. Okay. So what I will simply do over here is that now I'm just going to make use of this linear regression model, okay, in order to just fit my data set over here. Now you might be there might be question like why linear regression over here. So see, we would be using this linear regression only, but we will just add on some features, that is the polynomial degree, in our next step. Okay, because you can't directly just go with the polynomial. We don't have such type of this because everything I already told you guys that that is a single variable. Okay, that is linear regression with single variable, linear regression with multiple variables. That is also a type of polynomial itself. Okay, but it was by degree 1 over here. We are just going to import this linear regression over here. So how I am supposed to do that? I'm just going to say from sklearn import linear model. Okay. So what I will do is inside this linear model, I have this L capital, that is linear regression, I will just create an object of this thing. Okay, that's it. And I'm just going to make use of this fit in order to train my regression model by using this data points over here. So those data points are inside my x and y over here. So our data set, our model is just well trained with the available data points over here. This is the linear regression over here. Okay, now if I just our model is completely ready in case of if you just want to go with this linear regression. So if I just show you guys that predict over here. So say for example I want to predict something. So say I want to predict say the label over here. Okay, so say that I want to predict this 6.5 over here. Okay, now this is 6 and this is 7. Okay, this label. So for 6 you are seeing this thing, and for 7 is this. So it should be round about in between of this value over here. Okay, so what you are supposed to do now, let's find it out first. 6.5. So you can just observe. So if you just observe over here, it is giving you this 3 lakh over here, right? And if you just observe over here, so this is 1 lakh and this is 2 lakh, right? And so it is not giving in between of this. Okay, it is giving you 3 lakh around something. Okay, because this is as I said that your data points are just far away with that best fit line, so it is just expected you are going to get this prediction over here in linear regression model in this case. Now what we are just going to do is now we just want to predict by just implementing this polynomial regression over here. So what we are supposed to do over here is that we need to add the features, as I said that we want to change up those degrees over here. Okay, we want to make it 2 over here. So what we are supposed to do over here is that we need to just import this from sklearn dot preprocessing capital polynomial feature. Okay, and inside this polynomial features, so come up over here, polynomial features, we have this argument that is degree, and by degree, by default the value of degree is 2 over here. So I'm just going to keep it this by default over here, and I will just store this inside a variable call it as poly over here. Okay, so we're just adding this thing over here. So for that purpose, you need to just import this linear regression. You need to train up your data set by making use of this linear regression, and then you need to add up these features over here. Okay, directly you can't do. Okay, now we are adding this feature, so we are just making this degree 2 over here. Okay, fine. So as you know, so over here as this degree over here, so this degree parameter just specifies the degree of your polynomial feature of x over here. Now as we have just put up this by default over here, so we have this feature x. Okay, so one feature we are having, so we will get this x1 and then x1 raised to 2 over here. Okay, because we have set our degree to 2 over here. So next what we need to do over here is that by making use of this object, that is this poly, okay, I need to just fit my independent variable x, okay, along with this polynomial feature class over here. So what I'll simply do is I will just say poly and fit transform, and I need to fit my x over here, and let's show this inside a variable that is my x poly over here. So this x poly will just consist of all the polynomial combination of our x feature, that is our independent variable with degree 2 over here. Now what we need to do over here is that now we'll just call up this linear regression over here. Okay, so what I'm simply going to do is I'm just going to say this linear module dot linear regression, and let's just write this the variable name that is rep2 over here. And now we are just going to train our module, that is we are just going to fit our module by using this x poly, okay, and the y. Okay, so what I'm simply going to do is I'm just going to say rep2 dot fit. Inside this I will just pass up this x poly and this y. That's it. And now the module is completely trained fine in order to do the prediction. Okay, that is our polynomial regression over here. Now I'm just going to predict this thing. So I'm just going to say rg2 dot predict, and inside this what I need to do is I will just say this poly dot fit transform, poly dot fit transform, and inside this I'm just going to pass out the same value so that we just get a idea like. Okay, so see, it is giving you 1,89,000. Okay, and here it was just giving you 3 lakh over here. And if you just come up over here, you can just observe that we are getting quite good result, okay, as compared with this polynomial regression with respect to this linear regression. Okay, so this is how we have just implemented our thing. So this 6 and 7, so see 1 lakh and this is 2 lakh over here, and we are getting here round about 1,89,000. Okay, so through polynomial regression we are getting far better result as compared to this over here, that is a linear regression in this case. Okay, so this is all about the polynomial regression. So I hope that you are just clear with this concept. So if you just like this video, so hit the like button, do subscribe to our channel, and see you in the next video.